Hello students, I hope you all are fine. So as you know that we are discussing unit hydrocarbon. In that saturated hydrocarbon we already covered, that is alkane. So today we will start unsaturated hydrocarbon, and in unsaturated hydrocarbon also we will discuss about alkenes. Okay, first we will see general introduction. Alkenes means carbon to carbon double bond, carbon to carbon double bond there. Okay, and alkenes, they have general formula CnH2n. They have general formula CnH2n. Okay, and students, in alkene we use suffix in. Okay, isomers, already we have discussed isomers. They show mainly stereoisomer, geometrical isomer, cis and trans isomer. Okay, so today we will discuss about method of preparation. Before that, structure. We use carbon to carbon double bond here. Carbon to carbon double bond. Let us consider I am taking smallest alkene, that is ethene. Smallest alkene is ethene. Okay, so students, if I talk about the structure, here this one carbon, how many bonded atoms? Here bonded atoms are 1, 2 and 3. So bonded atoms with this carbon 3. Bonded atoms 3, lone pair, it has 4 valence electron and all are forming bonds. So lone pair 0. So students, hybridization may be bond pair plus lone pair. Bonded atom plus lone pair. So hybridization may be sp2. Hybridization will be sp2. Okay. So here this carbon is forming by overlapping 1 sigma bond with this hydrogen, 1 sigma bond with this one hydrogen, and 1 sigma bond with other carbon. 1 sigma bond it is forming with other carbon, and this one also 1 bond with hydrogen, 1 bond with hydrogen, sigma bond, and one single bond with this one carbon. But students, here 4 electrons are there na, 1 is unhybridized orbital. Clear or not? So this is forming pi bond. This is the pi bond. Then students, here hybridization sp2, and for sp2 angle will be 120 degree. Clear or not? Structure will be trigonal planar. Clear? So in alkenes, carbon hybridization will be sp2, angle will be 120 degree, and their structure will be the trigonal planar. Clear or not? Now, how can we prepare alkene? Method of preparation. Of alkene. First one method already we discussed, students, by hydrogenation. In hydrogenation of the alkyne. Okay, alkyne, if we do hydrogenation, means addition of hydrogen in presence of catalyst, nickel, platinum or palladium we can take. Then first of all, 1 bond will break. Yes. And we will give 1 hydrogen to both carbons. CH, 1 bond break. For breaking 1 hydrogen to this one. What is this? This is alkene. Alkene is ethene here because 2 carbons. So from hydrogenation of alkyne, we can get alkane. And if you will do further hydrogenation if you will do, then further one more bond can break and we get alkane. So this method already we have discussed. First one method by hydrogenation of alkyne. Then next is the from alkyl halide. Students, alkyl halide means when, let us consider if I have ethane. If one or more hydrogen replaced by halogen. If one or more hydrogen of alkane replaced by halogen, then they are known as haloalkane or alkyl halide. Alkyl halide is the common name. Let us consider I am replacing this hydrogen by chlorine. So this is the chloroethane, or common name is ethyl chloride. Okay, students, if we do reaction in presence of alcoholic KOH, then what will happen? Dehydrohalogenation reaction take place. Dehydrohalogenation reaction take place. What do you mean by dehydrohalogenation? D means removal. Hydro means hydrogen. Halogenation means halogen. Means removal of hydrogen and halogen take place. So student, what will happen? Here we will remove hydrogen and halogen. Simple, you can learn. We will remove hydrogen and halogen. So from here, one hydrogen we are removing. Okay. Here we are removing halogen. But carbon valency only 3 completed, but it is 4, double bond. Okay, means we can get alkene by dehydrohalogenation of the alkyl halide. Clear or not? Actually, what will happen, students? Try to understand. We are having CH3, CH2Cl. This one we are having now. Open structure you can write. You are having CH3, CH2Cl. You are doing reaction in presence of alcoholic KOH. Alcoholic KOH means KOH can release OH negative ions. It can release OH negative ions. OH negative ions, it needs some electrons. What will happen? Actually, what will happen, student? This halogen is more negative as compared to carbon. Okay, it will try to take electron towards itself. Okay, if it will take, then positive charge, partial positive charge will be there. If partially positive charge will be there, then this hydrogen will spot this one. This hydrogen will spot this one. And here, this will help to proceed with this reaction. Because water is the good living group. Water is the good living group. Okay. So here, if it will gain electron, then some deficiency of electron will create on this hydrogen. So firstly, this OH will attach on this hydrogen and it will make bond. It will make bond. Okay. If it will make bond with this one, so from here, H plus OH negative, we can remove water. We can remove water. If H positive is going there, then this bond shifted here, this bond shifted here. If this bond will shift it, from here water removed. From here, removal of water take place. This bond, this one bond shift here, then double bond. If this Cl is more negative, so it can take electron, it can take this bond, electrons of this bond, and it can be removed. It can be removed. Clear or not? After gaining electrons of this bond, after gaining electron of this bond. Clear or not? Then K plus already present in solution. K plus and Cl negative, they will form KCl. They will form KCl. Clear or not? Actually, what is happening here? Here removal of hydrogen and removal of halogen is taking place. That's why it is known as dehydrohalogenation reaction. Okay. In first step, student, what is happening here? This reaction is taking place in two steps. Taking place in two steps. In first step, here dehydrogenation taking place. Dehydrogenation. Okay. And dehydrogenation taking place, this is the slowest step. In first step, removal of hydrogen taking place here. That's why it is known as the beta elimination. This reaction also known as beta elimination reaction. Why it is known as the elimination reaction? Elimination means removal. Elimination means removal. Here students, elimination of HCl taking place. Elimination of hydrogen and chlorine taking place. So elimination of one molecule is taking place here. That's why it is known as the elimination reaction also. Elimination reaction also. And what type of elimination? It is known as the beta elimination. Beta elimination. Why known as beta elimination reaction? Because the carbon which contain group, any functional group, any substituent here, that is known as alpha. That is known as the alpha. So here halogen means group is attached to this carbon. That's why this carbon known as alpha. This carbon known as alpha. And adjacent carbon known as the beta. Clear or not? And in first step, removal of H positive taking place. Removal of H positive taking place. Clear or not? That's why removal of hydrogen taking place from beta carbon. That's why it is known as the beta elimination. That's why it is known as the beta elimination reaction. Clear or not? Any doubt? Yes. Students, here only two carbons and only one beta hydrogen. Only one beta hydrogen here. So simply we can write the product. Only one product will be there. Okay, simply we can write. We will remove hydrogen and halogen and there will be double bond between two carbons. Simply you can write. But students, sometime if you have 2-bromobutane like this, Like this, if you have 1, 2, 3, 4, 2 bromo, butane, CH3, CH, CH2, CH3. Try to understand, students. Here, this one is alpha carbon, this one is alpha carbon, because halogen group attached to this one. And adjacent carbon, Aditya, your attention should be here only. Adjacent carbon to this one are known as beta. So this is the beta carbon, and this one is also beta carbon. Clear? And hydrogen attached to beta carbons are known as the beta hydrogens. So students, here removal of beta hydrogens take place. That's why it is known as the beta elimination. But here beta hydrogens are these also and these also. So students, what is the possibility? I can write in this way. CH3, I can write in this way or not? CH2 and H. CH, Br. This one, CH, one hydrogen, open structure we can write. Then CH3. This one is alpha carbon and this beta. This beta. Okay. Yes. Then students, hydrogen either we can eliminate from this or we can eliminate from this. Try to understand. If we eliminate from this one, then what will be the product? Then product will be CH2, because you are removing this hydrogen only. You are removing this hydrogen and halogen. So double bond will be there, na? Double bond will be there. CH2. If you are breaking this bond and this one, so you will put double bond here. Yes. Clear? CH. Then you will write this one as it is, CH2 and CH3. One product may be this one. Yes. And second one possibility is this. Here you are not breaking this hydrogen. These beta hydrogens you are removing. If you will remove this one hydrogen and halogen, then you are removing this one, then double bond will be here. Yes or not? Yes. So CH3, this as it is, you are not removing this one. CH, you are removing this one hydrogen, so double bond will be here, and CH3. Both products are clear or not? Tell me. Try to understand, beta, what will you do? Try to understand. Simply you will break hydrogen and halogen. Simply you will break. Simply you will remove hydrogen and halogens. Which one hydrogen? Beta hydrogen. After removing these two, you will put double bond between those carbon. Clear or not? Only this thing you will do. But here only one beta hydrogen. In some reactants, if two or more beta hydrogens available, then you will get 2 or more products. Like this, beta hydrogens mean here, first the carbon which is having group, this one having halogens. So this is alpha. Adjacent to this one is known as beta carbon. This is beta. Here this one also beta, because this is also adjacent to this one. Clear or not? This is also beta. Means these hydrogens are beta hydrogens and these hydrogens are also beta hydrogens. Okay. Either removal of this hydrogen can take place or removal of this hydrogen can take place. If removal of this hydrogen take place, then double bond, if this hydrogen and halogen, then double bond will be in between them. So this will be the product. This will be the product. And if you will remove this hydrogen and halogen, then double bond will be here. Then you will get this one is the product. But students, here this one is the more stable. This is the more stable. Product. We can say this one is the major product. In organic chemistry, we discuss about major and minor product. This one is the major product and this one is the minor product. This was explained by the Setjeff. This was explained by the Setjeff. Setjeff rule. What do you mean by the Setjeff rule? Setjeff rule says that highly substituted alkene, will be more stable. Highly substituted alkene will be more stable. Highly substituted means the carbons which have less number of hydrogen, either we can say, or we can say this is double bond, because we are talking about alkene. So alkene means double bond. Inside of double bond, 2 carbons here, 2 carbons here. So this one is highly substituted. But here in this side only 1 carbon. Yes. In double bond side only 1 carbon with this one. Now further not substituted it is. Okay, it is not substituted. Substituted alkene means when hydrogens are substituted by others. Okay, so this one is more substituted alkene as compared to this one. Here 2 hydrogens only. These hydrogens are not substituted by other. Only this one substituted. Clear or not? So here both carbons are here. 1 hydrogen substituted by methyl. Here also 1 substituted by methyl. So which one is more substituted alkene here? This one. मीन्स जिसमें जो हमारी अल्केन्स में क्या होते हैं, कार्बन एंड हाइड्रोजन्स होते हैं. अगर जो डबल बॉन्ड से जुड़ी हुई जो हमारी कार्बन है, अगर उस पे हाइड्रोजन ही है. अब जैसे मान लो आपने भाई लिखना क्या है, इथीन लिखना है, तो ये आपका इथीन है. बट अगर मान लो मैं एक हाइड्रोजन को हटा के यहाँ पे CH3 लिखा, तो मैंने सब्स्टिट्यूट कर दिया ना एक हाइड्रोजन को, तो ये क्या है, सब्स्टिट्यूटेड है. यहाँ मैंने इस कार्बन के हाइड्रोजन को भी सब्स्टिट्यूट किया है मिथाइल से, ये मोर सब्स्टिट्यूटेड है. बट यहाँ पर क्या था, ये कार्बन तो है सब्स्टिट्यूटेड, इसका एक हाइड्रोजन मैंने इथाइल से सब्स्टिट्यूट कर रखा है. बट ये जो कार्बन थी हमारी, ये जो कार्बन है, इसके तो 2 के 2 हाइड्रोजन एज इट इज है, ये तो सब्स्टिट्यूटेड नहीं है. सो विच वन इज मोर सब्स्टिट्यूटेड हियर, दिस वन. ओके, सो Setjeff rule states that highly substituted alkene will be the more stable. Clear or not? Then students, this one is the more stable alkene. That's why it is the major product and this one is the minor product. Okay, so we can prepare alkene by alkyl halide. सिंपल रिएक्शन आपने बिल्कुल सिंपल ऐसे लिखनी है. जहां पर भी आपने बस ये देखना है जिस पर हेलोजन अटैच है, दैट इज द अल्फा हाइड्रोजन. उसके जस्ट साइड वाली जो कार्बन है, दैट इज नोन एज द बीटा कार्बन. बीटा कार्बन से जो हाइड्रोजन अटैच्ड है उनको हम क्या कहेंगे, बीटा हाइड्रोजन. आपने बीटा हाइड्रोजन को और हेलोजन को रिमूव करना है. रिमूव करके क्या करना है, आपने जस्ट जो जिन कार्बन से आपने रिमूव किया है उनके बीच में क्या आ जाएगा, डबल बॉन्ड, क्या आ जाएगा, डबल बॉन्ड, और आप अपना प्रोडक्ट आराम से लिख देंगे। क्लियर और नॉट? बाई प्रोडक्ट्स आपका यहाँ पे जैसे के एंड मैकेनिज्म से हमने देखा KCl निकलेगा और साथ में H एंड OH से क्या रिमूव हुआ था आपका, वाटर। ये आपके बाई प्रोडक्ट्स हैं। दिस वन इज द मेन प्रोडक्ट। क्लियर और नॉट? और अगर आपके 2 और मोर बीटा हाइड्रोजन्स हैं तो उसमें हम 2 और मोर प्रोडक्ट्स लिखेंगे। जैसे यहाँ पर ये अल्फा हाइड्रोजन था तो ये भी बीटा था, इसके साइड वाला ये भी बीटा था, इसके अकॉर्डिंग एक बार ये हाइड्रोजन रिमूव किया, ये हैलोजन, तो इनके बीच डबल बॉन्ड लगाया। दूसरे प्रोडक्ट में आपने ये वाला बीटा हाइड्रोजन और ये हैलोजन रिमूव किया तो आपने यहाँ पर डबल बॉन्ड लगाया। क्लियर? तो वहां पर आप देखोगे विच वन इज माइनर प्रोडक्ट एंड विच वन इज द मेजर प्रोडक्ट। ओके, वो आप किसके अकॉर्डिंग देखेंगे, सर्जफ रूल से। सर्जफ रूल क्या कहता है, जो हाईली सब्स्टिट्यूटेड एल्कीन है वो ज्यादा स्टेबल है। ओके, सो दिस इज हाईली सब्स्टिट्यूटेड, दैट्स व्हाई इट इज द मोर स्टेबल। क्लियर और नॉट? एनी डाउट? यस। देन स्टूडेंट्स, we can prepare alkene by dihalide also, by dihalides. Now what do you mean by dihalide, and what type of dihalide? Vicinal, vicinal dihalide, vicinal, geminal, already I discussed. Vicinal mean, first thing, this is alkane, CH3, this is alkane. If hydrogen of alkane replaced by halogen, then they are known as halide. They are known as halide. So student, I am replacing 2 hydrogens by halogen. Di mean 2. Yes. Dihalide. One option, both hydrogen of this carbon, I am replacing by halogen. Clear? Means 2 hydrogen I replaced by chlorine. If both hydrogens are attached to the same carbon, then it is known as geminal. Then it is known as the geminal. But if I replace 1 hydrogen of this one, 1 hydrogen of this one, and 1 hydrogen of this one carbon, if halogen are attached to the adjacent carbons, if halogens are attached to the adjacent carbons, then they are known as the vicinal dihalide. They are known as the vicinal dihalide. First of all, you should know about vicinal and geminal dihalide only. So we can prepare alkene by vicinal dihalide also. Clear? How? If we have vicinal dihalide like this, CH2Br, CH2Br. If it reacts with zinc metal, if it reacts with the zinc metal, then student, dehalogenation take place. Dehalogenation. D mean removal, halogenation means halogens. Then in same way, in alkyl halide, hydrogen and halogen we removed. Here we are having halide groups. So from here we will also remove this one, Br. From here we will also remove Br. Okay. So one bond we are breaking from this one from this one. So between these carbon we will put double bond. And Z and Br2 will remove, because this reaction we are doing in presence of the zinc bromide. Clear or not? Sorry, in presence of zinc only. Wait a minute, it is exporting now. Yes, so this reaction you will do in presence of zinc. These 2 bromide ion you can remove. So CH2, you are removing one bond here, one bond here. So double bond CH2 plus Zn and Br2. Zn, Br. So in simple way, you can prepare. One more is there by dehydration of alcohol. This is also simple. Dehydration of alcohol. Alcohol means here we will remove, we will replace hydrogen by OH group. Hydrogen by OH group. CH3, CH2OH. This one is the ethanol, alcohol, dehydration in presence of SO4. We will do this reaction. Okay. Simple way. D, removal. Hydration means water. You can remove water. After removing water, what will happen? You are removing, so you will put double bond here further. CH2, here double bond and CH2. All reactions are of same type. In this you are removing water, it is known as dehydration. In this you are removing halogen, dehalogenation. Okay. In that you are removing hydrogen and halogen, then dehydrohalogenation reaction. In this also, if you are having more than two, then you can follow Sergev rule. And students, here tertiary alcohol dehydration take place more easily as compared to secondary, or secondary take place more as compared to primary. Clear or not? Means here we are having concentrated H2SO4. But if we are having tertiary alcohol, this carbon having OH consider, and this is tertiary. This is tertiary alcohol. Yes. So here only around 30% of the H2SO4, or with simple water also we can remove water. If secondary we are having, then 80% of H2SO4, sorry, not 80, around means 50-60% or up to 80 it can be. Means we need not to take fully concentrated. In case of secondary and tertiary, reactivity increase. Tertiary can be dehydrated more easily as compared to secondary, and secondary more easily as compared to primary. Okay, so today we have covered all method of preparation of the alkenes. Any doubt in this? Okay, so thank you. Have a nice day.